Hello, everyone. My name is Shijie Lu. I am an associate professor of marketing from University of Notre Dame. In this video, I'm going to talk about some of the extent marketing research on live streaming and how live streaming can benefit from AI. Before we get started, I want to thank AMA, Artificial Intelligence SIG, for this great opportunity. Here is the agenda of today's talk. So firstly, we are going to walk through the history of live streaming. Then we're going to focus on different aspects that AI can play a role in live streaming services. After that, I'm going to go over the literature to showcase what kind of questions have been already addressed in marketing research on related to live streaming. And finally, we're going to look at a published study of live streaming. Spoiler alert, that will be research published by my co-authors and I. So this picture showcases the brief history of live streaming over the past 3 decades. In today's fast-paced digital landscape, live streaming has become more than just a trend. It's a thriving industry that's capturing the attention of business and audience alike. Whether it's a live concert, a gaming session, or a product launch, live streaming is now a powerful way for business to connect with their customers and fans in real time. However, the history of live streaming actually dated 30 years ago. On June 24, 1993, a couple of computer scientists and engineers from a band called Severe Tire Damage, they want to test a new technology, perform their gig online. So this was the first launch of the live streaming session. Of course, due to the poor technology at that time, the quality of this live streaming session was poor, but it was nevertheless a proof of concept. Some major events later, in 2005, YouTube was born, and in 2008, the YouTube, hosted its first ever live event, YouTube Live. But before YouTube took the plunge to make the feature publicly accessible in 2013, in 2011, Twitch.tv, formerly known as Justin TV, launched a new streaming platform designed for video games. It has gained popularity very quickly. It gained 45 million viewers per month in 2 years. And with the significant increase in popularity of mobile devices and the adoption of live streaming by social media platforms, live streaming has become the mainstream. So within the last decade, all major social media platforms have launched modern live streaming services. For example, YouTube Live has become publicly accessible in 2013. Twitter, which is currently X, has acquired Periscope to launch its own live streaming services. In 2016, Facebook and Instagram launched their live streaming services within their apps. And more recently, TikTok Live Video is launched in 2019. So Amazon has acquired Twitch in 2014 and launched Amazon Live, its separate online shopping platform for live commerce in 2019. So that's the history of live streaming. So live streaming is already a billion-dollar business. The global live streaming market is estimated to grow by $13 billion, accelerating at average growth rate of 13.5% between 2023 and 2028. So the graph I'm showing here is conducted by technavio.com in 2023. As we can see, like back in 2018, it's already close to $10 billion business. So the growth of the market depends on several factors, including the rising penetration of smartphones and the easy access to the internet. And the growing popularity of live streaming is also contributed mainly by Asian Pacific countries. Actually, Asian Pacific countries is estimated to contribute to almost half of the growth of the global market. So we need to keep in mind that the live streaming is not only popular in the US market or developed countries, it's a global phenomenon. Over the years, live streaming has become an effective and impactful way to accomplish goals and objectives in business that leverage video content. So live streaming saw a massive rise in popularity due to video games. So there is a lot of different content variety you might see on live stream, and the video game is probably the number one in terms of the content shares. Players flocked to Twitch, YouTube, and Facebook to showcase what they were playing, and the viewers followed. Also, the live streaming content includes music, concerts, sports events, news broadcasts, and more recently, we also see a surge in topics such as reality shows, everyday lives, talk shows. So it allows every ordinary individual to be able to showcase their talents on the internet. We also see a lot of educational seminars, including professional seminars and educational lecture series through live streaming content because it enables a real-time interactions which facilitate the knowledge sharing across the internet. So live streaming platforms also create a lot of monetization opportunities for content creators to earn additional income. So there are several conventional monetization methods we witness on the live streaming in the live streaming industry, such as advertising, subscription, sponsorships. But there is also some relatively unique monetization opportunities for live streaming, such as pay what you want. So these refers to the tips and donations that viewers send to the streamers. There is also e-commerce or live shopping, where the stream will promote a product and allows viewers to purchase the product during a live streaming session. So these are some relatively new monetization opportunities in live streaming. So next, we are going to discuss how live streaming can benefit from the rising AI technologies. AI has quickly embedded itself into the daily lives and the work of people from around the globe. The live streaming industry is not different. AI-driven chatbot has been increasingly used by streamers to improve the viewer engagement in a live streaming session. And there is a lot of interactive features of these AI-driven chatbots that can enhance audience engagement. Chatbots can answer viewer questions, conduct polls, and facilitate audience interactions. So this is especially helpful for streamers in the gaming industry, for example. So on Twitch, there's already a lot of existing chatbots available for streamers. So thousands of streamers on Twitch are already experimenting with various AI chatbots. So these AI chatbots are highly customizable, helping streamers to integrate them seamlessly into the branded content. For example, they can set up unique avatars with adjustable personalities, exclusive chat commands to interact with the AI. And these bots are revolutionizing the interactivity of the average Twitch streamer and viewers, and allow them to be able to maintain consistency with the brand style. So this is one example of the application of AI in the live streaming industry. And for streamers, there is also a few different ways that they can leverage AI to improve their performances. The first one is real-time audience engagement tracking and prediction. So AI-driven technologies can track user engagement metrics on real time and provide suggestions on the next move or topic. For example, AI-powered analytics tools can analyze live streaming data, including the chats and viewer behaviors on the screen to generate valuable insights for content creators, right? These AI algorithms can help identify trends, optimize content strategies. For example, they can make suggestions on the list of topics the streamer should talk about. Right? They can even come up with some jokes based on the real-time feedback from the audience. And secondly, these AI technologies can improve the video and audio quality during a live streaming session. AI technologies such as machine learning and deep learning can improve video and audio quality. They can optimize encoding parameters, perform noise reduction, and enhance image resolutions, and even beautify some facial, facial content during live streaming session to improve the performance. They can also mitigate streaming artifacts, resulting in a smoother and more immersive viewing experience for users. And finally, a big advantage of AI tools is automation, right? So AI technologies can automate various aspects of live streaming production and editing, reducing the need for manual intervention and streamlining workflows. For example, conventionally, after a live streaming session, the streamer need to handpick what's the best, bit of content to upload to the website, right? And with these AI-powered tools, they can automatically switch between camera angles and ask AI tools to find the most interesting, most engaging content to create some snapshot for their for their offline video content or recorded video content. So these are some potential use of AI for streamers. Now, how about platforms? The platforms can also significantly benefit from AI. Firstly, AI algorithms can help analyze user behavior, preferences, and viewing history to provide personalized content recommendations. By understanding viewers' interest and engagement patterns, live streaming platforms can offer tailored recommendations, leading to increased user satisfaction and longer watch times, right? So that's the first use. And secondly, AI-powered tools can monitor live streams in real time to detect and prevent harmful or inappropriate content, such as hate speech, violence, or nudity. So these are very serious issues in the live streaming industry, and they happen all the time. So AI can free content moderators from human beings to these computer algorithms. By automating content moderation tasks, platforms can ensure a more safer and welcoming environment for viewers and also for streamers, right? And finally, AI can be used for fighting against piracy or to protect copyright. For example, if a streamer is playing some movie content during a streaming session, this will be viewed as a copyright infringement, and it will be very costly for the platform to manually, monitor these copyright-related issues. But with AI tools, these additional copyright supervision tasks can be done by AI instead of human beings. So overall, AI technology has the potential to revolutionize the live streaming industry by enhancing content discovery, improving content quality, increasing audience engagement, and automating the content moderation task. So as AI continues to evolve and become more sophisticated, its impact on the live streaming ecosystem is expected to grow fast, right? Driving innovation and growth in the industry to the next level. So we are all very optimistic about the use of AI in live streaming. So next, I'm going to talk about some of the literature in live streaming research, especially from marketing. Now, early research on live streaming are actually not from marketing, but more from computer scientists. So earlier work typically focused on understanding the motivation behind streamers and viewer behaviors, and they typically rely on service. For example, the paper by Hamari and Sajid in 2017, they surveyed a bunch of streamers on Twitch and viewers on Twitch. They find that tension release, interpersonal bonding, and entertainment are the three key psychological motivators for viewers to watch streaming video games on Twitch. And similarly, through interviews with 20 frequent broadcasters on Meerkat and the Periscope, these are the two popular live streaming platforms back in 2015 or 16. Tang and his and et al. They find that most broadcasters use live streaming to build their personal brand, right? And then try to monetize their brand power through other channels. So these are some early research. Now within marketing, I would say the study of live streaming started from understanding pay what you want as a viable business model for live streaming industry. So pay what you want allows viewers to directly tip or send donations to the broadcasters during a live streaming session. And there is a series of studies that look at the drivers for these voluntary payments by viewers. For example, Lin, Yao, and Chen, this is a JMR paper in 2021. They focus on the streamer's emotion as the potential driver. They find that the streamer's positive emotion or the happy face referred in this paper will lead to more happy face on viewer emotion and lead to more viewer tips. And this will generate a positive feedback loop because more viewer tips will also trigger more happy streamer emotion in the next phase. And therefore, this can generate a positive feedback loop in the live streaming session. And there is also two other studies that focus on some social factors. For example, in Lu, Yao, Chen, Gruwell, 2021, a marketing science paper, these folks, they used a field experiment to study the impact of audience size on viewer participation and the tips. And they find generally a positive effect of audience size. So this is one example of the social factor. Another social factor is how does others' tips amount affect my own tipping behavior, right? So in a follow-up study, Yao, Lu, and Chen, 2024, a paper published in Production and Operations Management, they look at how viewers tip affect peer viewers' tipping behavior and streamers' emotional reactions. And they find a general crowding out effect. That is, when others tip more, a central viewer will tend to tip less, right? So there is a negative spillover effect of viewers' tips. And with the rise of live streaming shopping, there is also a burgeoning literature that addressed different types of questions in this area. For example, within a live streaming session, firms might be interested in learning how to send targeted coupons, right, during a live streaming session. And Xiao Liu from NYU has developed a reinforcement learning-based solution. So this paper has been published at Marketing Science. Another use of live streaming is to recruit influencers to help the brand to promote their products in the live streaming shopping session. So Xian Gu from Indiana University and her co-authors has published a paper in Journal of Marketing. They find that although firms sometimes use big and small influencers in terms of the number of followers in practice, but generally speaking, it's not a good strategy to employ both of them simultaneously to promote your product because there is a negative interaction effect between small and large influencers on product sales. And then finally, there is another JM paper by Barawaja and co-authors. They focus on how salespeople should perform when selling products in live streaming shopping. In particular, they look at how salespeople's face presence, whether they should show their face in front of the screen, and what kind of emotions they displayed might affect sales performances. And they show that both face presence and emotional displays have a nonlinear effect on sales. And there are some also other topics has been studied in the live streaming literature. For example, Andrei Simonov from Columbia University and his co-authors has a JMR paper in 2023. They propose a method to quantify the suspense and the surprise elements in a live streaming session. And they focus on the esports industry. So the measurement of suspense and surprise are very important. And they showcase the way to measure these two elements from the unstructured data. And finally, Ziwei Tong from Georgetown University and her co-authors has a working paper. They look at the price decisions of a live event. In particular, they employed a double machine learning method to causally identify the price effect of a live event and compare this price elasticity before and on the day of and after a live streaming session. So this study also provides important implications for the pricing decision of a live event. So in summary, the live streaming literature is still growing fast, and there is also lots of unexplored aspects of live streaming that waiting for researchers and practitioners to work together to address them. So in the next in the rest of the presentation, I'm going to focus on one particular study. This is a study by Dai from Hong Kong PolyU and Celine Chen from Shenzhen University and Raj Gurwell from UNC and me. So this paper is published in Marketing Science in 2021. So in this paper, we focus on the effect of audience size on viewers' tipping behavior in a live streaming platform. So this research is motivated by pay what you want business model. At that time, the pay what you want business model was just employed by all the live streaming platforms. So this research was motivated by the observation of a super chat function on YouTube Live. So YouTube has launched this function in 2017, which allows the viewers to donate a certain amount to their broadcaster or streamer to have their chat highlighted, right? And they mentioned that this function allows the viewer to get even more of your favorite creator's attention. So this motivates to think about what's the role of pay what you want business model in live streaming industry. And we see that the pay what you want has been quickly adopted by all major social media platforms after YouTube's launch. For example, on Facebook Live, viewers can send these donations through the form of virtual gifts or tipping, right? So some of these virtual gifts even have animation, like the rainbow animation you see on the right screen here. And the streamers can also cash them out, cash all these virtual gifts out with a certain commission fee from the platform. Also, this is another example on Amazon's Twitch. The viewers can send these diamond-like gifts called bits on Amazon's Twitch. So they need to purchase these bits with real money, and then they can tip their favorite broadcasters with these bits. According to Deloitte in 2018, based on this report, they find that the live streaming revenue has reached $7 or $8 billion in 2018. It has experienced a 50% increase over the past year, and they identify tipping as a primary revenue model for this market, right? So where viewers can donate money directly to the performers. So this is pretty a new phenomenon in the live streaming industry, and this prompts us to think about why viewers tip and how viable this tipping-based business model might be compared to conventional business models that relies on advertising and subscriptions. So this motivates the following research question. First, we want to look at how audience size affects tipping revenue, right? So the reason we focus on audience size is because let's think about the nature of offering by live streaming, right? So live streaming seems to be simply a service that's using pay what you want pricing scheme. However, it also has social features, right? It's not like you are selling a concert ticket directly, but actually you are selling these services or products in a social context where all the viewers or all the audience can observe each other's behavior. So therefore, it drives us to hypothesis that a viewer will not only get utility from the broadcast attention or performance, but also they might get utility from interacting with others, or even gaining prestige or image-related utility in front of others, right? So if that's the case, we expect audience size to be able to affect consumers or viewers' tipping behavior. And so in this study, we focus on the effect of audience size on both tipping and live streaming participation conditions. And furthermore, we want to say something about the underlying mechanisms. Think about it. If seeking the broadcaster's attention or reciprocity is the main driver for this tipping behavior, we would expect a negative effect of audience size on tipping amount. This is because when the audience size, when the live streaming session becomes more crowded, the competition for broadcasters' attention or reciprocity will become more fierce, and therefore it will discourage viewers to tip. However, if gaining social image from other viewers in front of a broadcaster is the main driver for tipping, we would expect a positive effect of audience size on tipping. And similarly, we want to identify whether there is some herding behaviors in terms of how viewers choose which session to join, right? Are they going to join a session with more viewers or fewer viewers? So, and what might be the reasons behind this herding behavior? So these are the questions we attempt to address in this research. By addressing these questions, we can make a few contributions. For example, so this study, to our knowledge, is one of the few studies that use field data instead of survey data to study viewer behavior in the live streaming industry. And previous research before this one are all based on survey data. We also contribute to the social media literature by studying social influence on paid engagement, right? Previous literature typically focused on free engagement such as likes, chats, or shares. But here we have a new form of engagement in the form of tips or sending virtual gifts. This research also contributes to the pay what you want literature by demonstrating the importance of social image in a non-charity context. So this is different from previous pay what you want literature that typically focus on the charity context, such as donations or charity gift giving behavior. We addressed our research question by running a field experiment with a partnering company in 2016. So we worked with a Chinese live streaming firm, which is top 30 at the time of study. They have a decent number of monthly active viewers, which is over 600,000. They have 40,000 broadcasters on the platform. So in this experiment, we asked the platform to identify about 150 broadcasters, and then we randomly assign these broadcasters into 3 groups: control group, treatment group 1, and treatment group 2. Now, in the control group, we will not interfere their live streaming sessions. They will just broadcast as usual. However, for the treatment group, we will add a random number of synthetic viewers. So for the treatment group 1, we will add a random number of synthetic viewers with a mean of 2 per minute. starting from the 10th minute of a session. And for treatment group 2, we will double the treatment strands by adding an average of 4 synthetic viewers per minute, right? So, and for the control group, we will not manipulate the audience size. So we start experiment between August 11th, 2016 and September 12th, 2016, which lasts about a month. And we also have 1 month of pre-experiment data for to construct some important pre-treatment variables for these viewers and broadcasters. So the data we observed is at the session and the minute level. So in the end, we have data for over 2,000 streaming sessions, pretty evenly distributed across the 3 groups. And for each session, we observe the following metrics at each minute level. So in this study, we do not observe the data at the viewer level. However, in the follow-up study, which is the paper published in PALMS in 2024, we ran a new field experiment. And in that experiment, we collected the data at the viewer and minute level. But for the focal study, for each minute, we observe the number of real and the synthetic viewers, and what's the amount of their tips, what's the total number of people who tipped, and also the number of chats and likes. We also saved all the video recordings, and we analyzed this video content to construct some control variables about the broadcaster behavior. So this is about our research setting. Here is the interface of a typical live streaming session. At the left top, so here you can see the number of viewers, which is the audience size. So in this example, you can see the number of viewers is 88. And this number will be updated on real time. And the viewers can do 3 things in a live streaming session. They can press this like button, which will send a number of likes in the floating Pokemon ball shape in this particular session. They can also leave chats, which will be displayed in the central of the live screen. They can also send tips. That's the focal dependent variables in the study. So these tips are usually in the form of virtual gifts, such as this rose, right? So this rose represents the smallest amount of tip, which costs only 1 cent. But the viewers can send more expensive tips in the form of like a luxury car or even a rocket. So these tips cost a lot of, like maybe 100 of, if not thousands of dollars. So the range of the monetary value of the tips can vary quite a lot in live streaming sessions. Here, so far we have finished describing the research context. Now let's look at some model-free evidence about the treatment effect. So the first thing we look at in data analysis is the randomization check, right? We want to ensure that the broadcasters assigned to each of the groups are comparable. So here we collect a series of variables like the amount of tips per session, the number of chats, the number of likes, those engagement metrics. We also look at the duration of the session, how frequently they broadcast, the gender and the popularity metrics. We find that we did not find any significant differences across the groups. For example, the number of sessions is about 16 per month, which means each broadcaster will broadcast almost every 2 days. So the randomization check seems to be passed based on this table. So the next thing we did is to look at the raw data and to analyze the relationship between our treatment variable, which is the number of synthetic viewers added in a session, and the revenue, right? So here we focus on 3 independent variables. The first one is the amount of tips per minute in a session. And the tip rate is the amount of tip divided by the number of real viewers. So that's what we call tip rate. The amount of tip value divided by the number of real viewers per minute per session. And finally, is the number of real viewers in a live streaming session at each minute. And we plot each of these three dependent variables against the number of synthetic viewers. And overall, we find an inverted yield relationship between the number of synthetic viewers and the tip rate, and a generally positive relationship, right? So this uptick in the right end of the session is mainly driven by outliers. So most of the sessions occurred over here. You can see a generally positive concave relationship between number of synthetic viewers and number of real viewers. So this suggests that there is some positive effect and some nonlinear effect between the number of synthetic viewers or audience size on each of these three dependent variables. Next, what we did is to summarize, to aggregate the data to the broadcaster level, right? So here what we did is we aggregate these minute and session level data to the broadcaster level and do a mean comparison. So here, compared to the control group, we find that for both the tip and tip rate, the amount is much higher in the treatment group than the control group, suggesting a positive effect of audience size on viewers' tipping behavior. And for the number of real viewers, we also observe a higher number of real viewers in the treatment group compared to the control group, suggesting a positive effect on viewer participation. However, we do not find that this effect is driven by the viewing duration, right? So we see that the average length of live streaming session is not significantly different across these numbers. And we also did not see a big change on the number of sessions conducted by broadcasters between control and treatment groups. So from this main comparisons, we already have some original, preliminary evidence on the positive effect of audience size on viewer tips and viewer participation. However, this analysis is subject to two sources of aggregation bias. Firstly, as I explained earlier, our treatment did not start during the first 10 minutes, right? So in this case, we are actually discarding, I would say that the data actually is putting less weight on these short streaming sessions and putting a higher weight on these long sessions. And also from our experiment design, we know that the number of synthetic viewers added at each minute is a random draw, right? So we haven't explored that source of randomization in the identification. And also the treatment strength, it also implies that the treatment strength is different across time, and therefore this sort of comparison might not be a most informative way in showcasing the treatment effect. Another thing we can show mathematically is that if the treatment effect is non-linear, this kind of aggregation to the broadcast level will lead to a biased estimate. So all these discussions motivates to use more granular source of data variation to identify the effect of audience size. The next set of exercises we did is to conduct slope comparisons. That is, we want to look at the reach dynamics in our data within a session, and we compare these slopes across the treatment conditions. First, let's look at how does the number of real viewers, denoted by unreal, vary across time, over time across the treatment groups. Here we can see two plots. On the left, we can see how does the number of real viewers evolve over time during the first 10 minutes, where we haven't started the manipulation. And we can see that there is not much difference, which confirm the success of the randomization. Remember, we started adding synthetic viewers after the 10th minute. And on the right plot, we focus on the range when t is between 10 minutes and 120 minutes, because most sessions do not last over 2 hours. Here, we can clearly see that the blue line, which is the slope for the treatment 2, is much larger than the green line, and which is further greater than the red line, which is the control group. The red line represents the control group, meaning that the number of real viewers will stay steady if we do not add synthetic viewers into a session. So this suggests a positive treatment effect of the audience size on the number of real viewers. Now, how about the total tip amount? Again, we did not see much difference during the first 10 minutes, but after the first 10 minutes, we can see that the total tip amount will gradually decrease over time in the control group. However, for the two treatment groups, the total tip amount is slightly increasing or either flat, suggesting that there is a positive treatment effect of the tip amount of audience size on tip amount. Lastly, let's look at how does the tip per viewers vary over time across groups. Here we can see that, interestingly, the blue line, which is treatment group 2, lies between the green line and the red line, suggesting that the treatment effect of audience size on tip per viewer seems to be nonlinear, because it seems to first increase from control to treatment group 1 and then drop from treatment group 1 to treatment group 2. So this is to some extent consistent with the mean comparison table we showed earlier at the broadcast level, right? So again, this suggests positive treatment effect, but it seems to be nonlinear as we increase the treatment strength. So far we have documented a positive treatment effect of audience size on each of the outcome variables. However, this exercise does not allow platform to quantify the treatment effect, because from the platform's perspective, they will be interested in knowing how many additional viewers will be joining the session once we have more viewers in a session, and how much revenue can be generated when we have more viewers joining a session, right? So these questions can only be answered by regressions. So that's why we further resort to regressions to estimate the treatment effect. So we set up two equations to conduct regressions. So the first equation is about the impact of audience size on tip and tip rate. So here the y variable represents either the amount of tip at each minute of a session, where k represents a session and t represents a minute, and the key, or it can be the tip rate, which is the tip amount in a minute divided by the number of real viewers. So that's what we define tip rate. And on the right-hand side of the equation, we include the number of viewers for display, which is audience size, and a square term to capture the nonlinear effect. We also include two time-related factors. One is the chronicle time in a session. The other is what's the average length of stay for real viewers, right? So different viewers might join a session at different time, and therefore their experience in a session is captured by this tenure KT variable. We also include the session fixed effect to capture any time invariant session unobservable, such as the session quality, the ambient of a session, etc. Here, the number of displayed viewers is obviously endogenous, because it can be correlated with the error term through some unobserved broadcaster behavior. For example, if the broadcaster says something interesting, it might drive the number of audience size and tipping at the same time, right? So we need to correct for this endogeneity, and the way we do it is to use the number of synthetic viewers as an instrument. This number of synthetic viewers satisfy the instrument's because first, it naturally correlates with the number of display viewers by definition, because the number of display viewers equals the number of synthetic viewers plus the number of real viewers. And secondly, the number of synthetic viewers is generated by computer algorithm, and therefore it can be regarded as exogenous variation, right? So that's why it's a legitimate IV for number of display viewers. So we estimate this equation using the panel IV linear regression. And the second equation we set up is to study the effect of synthetic viewers on the number of real viewers. And we use a pretty similar model specification. However, we also include the lagged DV here because the number of real viewers consists of two parts. First is for those who are already in the session during the last minute, they need to decide whether to stay or not, right? And then the number of synthetic viewers added to the session might draw some of the new entrants to join into the session. So therefore, we want to capture the lag DV to capture consumers' inertia from the previous minute. And here is our regression results. For the total tip per minute, we see a generally positive effect of the audience size on its amount. So on average, adding one additional viewers into a minute can lead to 1.4 cent generated by a session. It's not much, but adding 100 more can generate $1 per minute. It's still regarded as pretty large because the average average amount per minute is also very small. And although this effect is nonlinear because the square term has a negative coefficient, we find that within our data range, it's mostly positive. The effect on the tips is mostly positive. We also find a nonlinear relationship or positive concave relationship between audience size and tip rate. And finally, we find that the effect of audience size on the number of real viewers or viewer participation is also mostly positive. So these are our main empirical findings. With these empirical findings, we next want to explore the underlying mechanisms that drive these effects. In particular, we want to explore the mechanism for both the positive effect of audience size on tipping and the positive effect on participation. Regarding the effect on tipping, we want to differentiate from two mechanisms. One is a direct effect. The reason a viewer tends to tip more in a crowded session may be because the improved social image utility in front of others, right? So that's a possible direct route through which audience ads might affect tipping. Alternatively, there could be an indirect effect. In a more crowded session, the broadcasters might be more motivated to improve his or her performance, right? By making more funny jokes, by being more energetic, which in turn might drive viewers to tip more, right? So we want to say which one might be the main driving force in our data set. And secondly, the positive effect of N on participation is a strong evidence for herding, but the reason for this herding could be either irrational, maybe the viewers just follow some social norm. For example, if one session is regarded more popular a priori, they might just join this popular session. So that would be an irrational herding, which means they are complying with the social norm when deciding which session to join. An alternative explanation will be a rational herding, or called observational learning, which means the viewers can use the number of audiences in a session as a signal to infer the quality of a session. If a priori less popular session now has more viewers, it's a strong signal that the quality of the session is currently high, and therefore the viewers might join this session because of the observational learning. So we want to use our data to disentangle which one is the main reason for the herding observed in our data. We first look at the moderating effect of broadcaster gender to say something about whether the herding is rational or irrational. So from the data, we see a pattern that the female broadcasters are better attended, and we use a pre-treatment period to find that the audience size difference is pretty large, which is 8. On average, the audience size is between like 10 or 20 in a session, so 8 is pretty large. And the most viewers are male viewers, and the most broadcasters are female. So this is a typical case in the in a reality show in a reality show focused live streaming platform like ours in this research. So our prediction is that if herding is mainly driven by social norm, we will expect the effect of audience size on viewer participation to be stronger in female session because most people know that female broadcasters are better attended. However, if the herding is driven by observational learning, we would expect the effect to be stronger in less popular sessions, which are male sessions, right? Because if a male broadcaster has the same number of audience as a female broadcaster, this will imply that this male broadcaster's session is of higher quality and people might join more in these male sessions if the effect on audience viewer participation is driven by observational learning. And also, theories from evolutionary psychology suggest that men are more likely to display financial resources as a tactic to signal their status and gain attention from female mates, which results in a higher level of conspicuous consumption by men than women. In our context of live streaming, this theory of intersexual competition predicts that such status signaling motivation among male customers is more likely to appear in the presence of a female broadcaster. And therefore, we will expect that if social image concern really drives the effect, we will expect a stronger effect of audience size on tip rate in female sessions. And then we test these predictions from the data. Here are the results. And what we did here is we separate all the sessions between female broadcasters and male broadcasters. On the left, you can see that there is indeed a positive effect. So first, let's look at the effect on viewer participation. By comparing these two magnitudes, we can see that the effect of audience size on number of real viewers is stronger in female sessions. So this result is more consistent with the irrational herding, which means this effect is likely driven by social norm rather than observational learning. And secondly, by comparing the effect of audience size on tip rate between female and male broadcasters, we do find the effect is stronger in female broadcasters. In fact, the positive effect of audience size on tip rate is no longer significant for male broadcasters. So this suggests that it's likely that the motivation for tipping in female broadcast session is driven by social image concern, right? Because most tippers are male and they want to have social status in front of a female streamer. And then we also test these theories by looking at the potential moderating effect by broadcaster fame. And similarly, a priori, we argue that more famous broadcasters are better attended, and this is also supported by our data, where we measure a broadcaster's fame based on the total amount of tips they received during the 1 month pre-treatment period. The higher the amount of tips they receive, they are regarded as more famous. Again, if the herding is driven by social norm, we expect a stronger effect of audience size on the number of real viewers in sessions by more famous broadcasters. And also, we expect the social image utility to be stronger when you tip in a more famous broadcaster session, and therefore we expect a stronger effect on tip rate moderated by the broadcaster's fame. Now let's look at the results. First, so here, since fame is a continuous variable, we use the interaction to test these hypotheses. For the effect of the number of real viewers, we do find that the effect of audience size is amplified when when the live streaming session is conducted by a famous broadcaster. So this again provides empirical support to the irrational herding mechanism. And for the effect on the tip rate, we do find positive moderating effect of fame, but this effect is not strongly statistically significant. So this provides some partial evidence for the social image utility mechanism. All right. And finally, we also want to test the moderation by broadcaster performances. So our thought is the following, that if the positive effect of audience size on tipping is indeed driven by social image concerns, then when the broadcasters tend to use recognition-related words by saying hello, welcome, thank you, or many thanks to a particular viewer, then this type of social image utility will be amplified in front of others. However, when the broadcaster is doing some behavior target the general audience, we do not expect this broadcaster performance to amplify the social image utility, and therefore it should not moderate the effect on tipping. One challenge in quantifying broadcaster performance is that most of the data from the live stream video is in unstructured form, and therefore we need to analyze the video contents to create these metrics. So we create 4 sets of metrics. The first is we call the recognition, which is the count of 4 key recognition words in the streamer's transcripts. So we look at the frequency of the use of welcome, hello, thank you, and many thanks during each minute to create this recognition variable. And secondly, we quantify the amount of times the broadcaster's face were showing in front of the camera, and the amount of times the broadcaster's hands are appearing, are like waving to the audience in front of the camera. And finally, from the facial duration, we create emotional score of the broadcaster. The higher the score means the higher the sentiment of their emotion. Now here are some details how we apply machine learning and deep learning methods to conduct these sound and speech recognitions. Now first, we divide each second into 1,000 samples, and then we extract various acoustic features for each sample. Then we build an in-house 3-class support vector machine classifier to classify each second into whether the streamer each streamer was speaking or not saying anything or playing music. And then we also transcript the audio to text to identify the frequency of using recognition-related words in each minute. Now, for the image analysis, we first, our goal here is to first identify the face detection, and we also want to detect the hand movement, right? So we build an in-house algorithm to use the skin color of the face to identify whether there is also skin color around the face. So if their hands are waving, they tend to wave their hands near their face, and therefore we should identify the skin color in the 2 rectangle areas around the face. If so, we say there is a hand movement or hand wavement in the screen. And from the facial expression, we also use Microsoft Azure Emotion Service to classify each face into emotional score, and then we summarize this emotional score into emotional score variables representing the overall emotion sentiment of the streamer. And here is our main finding here. So we do find a strong moderating effect of the broadcasters' use of recognition-related words. So when they tend to use recognition-related words, the effect of audience size on tip rate is much amplified and much stronger, right? So this is consistent with the social image-related utility we proposed in explaining the positive effect of audience size on tipping. We also conduct a series of falsification tests. For example, for each of the 3 other broadcasters' behavior, like face time, hand time, and emotion. So these variables are not conducted for a particular viewer, and therefore we do not expect these variables to lead to a stronger social image utility, and therefore we do not expect them to have a moderating effect. And our data is supporting this argument. We did not find any of these moderators to be significant. And finally, we argue we want to investigate whether the positive effect on tipping is driven by the broadcaster's improved performances. So this is a challenging test because we do not have additional instrument that can serve as exclusion restriction for broadcasters' performance. So here we assume that the broadcast performance in the last minute might affect viewers' tips. Our data do not support that based on the 4 broadcasters' performance we identified from the unstructured data. So we admit that this is not exhaustive list of broadcasters' performance, but based on the 4 major broadcasters, facial and hand movement we coded from the data, we did not find strong support for the link between broadcasters' behavior and viewers' tipping behavior, viewers' tipping amount. So this suggests that it's likely that the effect we observe on tip is directly driven by consumers' increased social image utility rather than the indirect improved broadcaster performance. And through the moderation effect of broadcaster's fame and the broadcaster's gender, we also provide evidence that the positive effect of audience size on participation is mainly driven by social norm as opposed to observational learning. So these are the main findings of this study. Now, in conclusion, I hope that you see that how AI tools can be used to better understand unstructured data in this study, and how field experiments can provide a powerful method to causally identify the effect of interest, right? So in this research, we mainly focus on the effect of audience size, which is a prominent feature in the social environment of live streaming industry. And we found a mostly positive and concave effect of audience size on tipping. And we provide strong evidence of herding in live streaming context. And our results suggest the importance of social image concerns in driving voluntary payments in the live streaming sessions. So what are the managerial implications we can draw from these findings? First, the first implication is on the viability of using pay what you want as a standalone monetization measures for live streaming. We argue that platforms should not only use pay what you want to monetize the online traffic from live streaming, because it might not scale well due to the concave relationship between audience size and tip amount. However, for advertising and subscription, you might have a better scalability with respect to the audience size. So one suggestion is these platforms should use a pay what you want in combination with more conventional monetization methods such as advertising and subscription in live streaming industry. Another implication is that the platform should not manipulate the audience size directly, because having additional, enlarged audience does not necessarily lead to a more tipping amount, right? As we show in our data, if the audience size exceeds 500, actually the live streaming session will accrue fewer tips than than a session with more engaging and more fewer people. And finally, because of the importance of social image concerns in driving tipping behavior, platforms can offer additional status-seeking devices or incentives, such as digital badges or status-related avatars or ranking systems, right? For example, they can showcase the ranks of the current ranks of the tip amount in front of everyone to incentivize additional tipping behavior. So this can improve the revenue for streamers and the platforms. So I hope that this presentation in general can inspire you to think more, to create additional, to serve as a way to inspire you to think more deeply about the live streaming industry and the role of AI technologies in enhancing the overall live streaming experiences for both viewers and streamers. So I hope this you find this recording helpful in your live streaming practice or live streaming research. Thank you.